So we learned yesterday some Pythagorean trigonometric identities. Now I just want to review with you and kind of come up with what these are again, and then we're going to use them today. Okay, so we know that sine squared plus cosine squared equals 1. Again, our reasoning for that comes from the unit circle, because we know that in the unit circle, in a random triangle in the unit circle, the x value is cosine, the y value is sine. So there, and the hypotenuse or radius of the triangle is always 1. And the Pythagorean theorem tells us that the leg squared plus the leg squared equals the hypotenuse squared. So the Pythagorean theorem using the unit circle trigonometric values is sine squared plus cosine squared equals 1. Okay, and then yesterday we actually came up with a few more. We came up with 2 more Pythagorean trigonometric identities. Does anyone remember how we can come up with the other 2? There are 3 total. This one involves sine and cosine. We have another one that involves tangent. Can anybody tell me how to come up with the one that involves tangent?
I don't know. I thought I had everything by cosine.
If we divide by cosine, we'll get a sine over cosine, which is indeed tangent. So if I take sine squared plus cosine squared equals 1, and I divide everything through by cosine squared, I'll get, now cosine squared can divide each of these, I'll get tangent squared theta plus 1 equals secant squared theta, because 1 over cosine is secant, right? So that is another Pythagorean trig identity. 1, 2, this one involves sine and cosine, this one involves tangent and secant. We have one more that involves the other 2 trig functions. Anybody tell me how to come up with it? Divide by sine squared instead of cosine squared. So now if I take sine squared plus cosine squared equals 1 and divide both sides by cosine squared, how about sine squared? That's what you said. Divide by sine squared theta. I'll get, let's see, sine squared over sine squared gives me 1. Cosine squared over sine squared is going to give me cotangent squared. And 1 over sine squared is going to be cosecant squared. So that's the 3rd Pythagorean identity. All right. We're going to use those 3 Pythagorean identities and anything else that we know about trigonometry so far, and we're going to try to do a proof. Okay, now in geometry, admittedly, I did not like proofs, but that was mostly because there were more theorems and postulates and definitions and things as your reasons. Here, you're not necessarily going to have to give me your reasons. What you are going to need to do is work through the problem so that your 2 sides of an equation are equal. So I would call this a more algebraic proof than a geometric proof. You're not so much giving me reasons as you are working through this using what you know. Okay, however, it is a proof. You cannot assume equality. So that means you can't do the same thing to both sides of the equation. You don't know that you're equal. You're trying to prove that you're equal. Does that make sense? Sort of. Okay, let's try this. So if I say verify that cotangent squared of an angle is equal to 1 over sine squared theta minus 1. You're trying to verify this. So you cannot assume these two things are equal. You can't do something like add 1 to both sides of the equation, because you don't know that these two things are equal. You're trying to prove that they're equal. So you're gonna, I usually put like a dotted line, and so that I kind of visually tell myself I cannot cross that dotted line. Okay, I can work on each side of this dotted line individually. What I'm trying to do is I'm trying to get this side to be exactly what's on this side. I can meet in the middle. Okay, I can work on this side and get something, and work on this side and get something, and if those are the same somethings, I've proven that they are equal. Okay, so what do we know that's going to help to get this side to look like that side or vice versa? How are you going to start this problem? You're trying to verify. Trevor, what do you think?
With the cotangent, it being the cosine squared over sine squared. Help us in any way?
Cotangent squared is, say that again? Cosine squared over sine squared?
Yeah.
That's true, so maybe that'll help me. So this is cosine squared theta over sine squared theta. Okay, then where do you go? I'm trying to get this side to look like this side, and they don't look alike yet.
All right.
So I'm not done. I do know that that's true, though, so that might help me. What else do I know that's true that might help me? We're just kind of brainstorming a little bit. We'll find a right path here in a minute. Let's kind of keep going with where you started going. 1 over sine squared is what? Cosecant squared. Is that what you were going to say, Olea? Yeah, sorry. I was thinking you might say something different, but no. Cosecant squared is 1 over sine squared. So this side is really cosecant squared minus 1. Okay, they still don't look exactly the same yet. Now what can I do?
When will be notification?
These are equal. We're trying to prove that they're equal. Anna, what do you think?
Can you just, oh, never mind.
What were you going to say?
I was gonna say add the 1 to the other side, but that doesn't really do anything.
You can't do that on this. However, are you looking up here?
Yeah.
Okay, I have 1 plus cotangent squared equals cosecant squared. This is a true equation. I can manipulate that equation. So I can do things like subtract the 1 from both sides on this one. Okay, would that help? Like if I take 1 away from both sides of that equation, I would get cotangent squared equals cosecant squared minus 1, right?
So isn't it just already in the same form?
So this is cotangent squared theta. And I don't really need that at this point. We could have, there would be some methods of proving this is true that you would need that, okay? But we didn't need that for doing it this way.
Wait, why did you bring the cotangent on the other side? Like, why did you write it under cosecant?
Right here?
Mm-hmm.
Because this thing right here is equal to cotangent squared.
Why did you write cotangent, like you were just saying like that's equal to it? Okay.
So I can replace cosecant squared minus 1 with
Yeah.
cotangent squared,
Okay.
since they're equal.
Gotcha.
And then I have cotangent squared equals cotangent squared, so I've proven the equation. Does that make sense? This is not the only way to do this problem. Some people might have said, well, I have subtraction right here, let me get a common denominator. Okay, so let me show you another way to do this same proof. Okay, This is an alternate way. This is not, you don't need to do it both ways, okay? So I might say, instead of changing 1 over sine squared theta into cosecant squared theta, because not everybody's brain works the same, okay? Instead of changing that into cosecant squared, we're going to say, let's say you went, okay, I want to get a common denominator, all right? So the common denominator between these would be sine squared. So you would get like 1 over sine squared theta minus 1 is the same thing as sine squared theta over sine squared theta. And then once I have a common denominator, I can subtract the fractions. So I get 1 minus sine squared on the top. On the bottom, I get sine squared theta. Does this make sense so far? Now, Trevor, a minute ago, you changed cotangent squared into cosine squared over sine squared, right? Cosine squared is the same thing as 1 minus sine squared, because sine squared plus cosine squared equals 1. So 1 minus sine squared is equal to cosine squared. Does that make sense?
Yes.
Okay, so that thing right there I can change into cosine squared theta. So I get cosine squared theta over sine squared theta, which is what I had over here a second ago. Because I have the same thing on both sides of the dotted line, I've proven the equation is true. So you do need the cosine squared over sine squared in that case. Okay? It doesn't matter to me which way you go about this. There's probably other ways that you could come up with as well. Those are the first two that come to my mind. Okay? That's not saying that that's how you would do it. You have to get both sides of the equation to be the exact same thing, working with only things that you know. You can't use this as part of it. Okay? You can use the Pythagorean identities, though, because those are true. Does that make sense?
Yeah.
I don't know if I take a picture of that. It's pretty messy. If you haven't seen it worked out, it's kind of messy. You want to do another one?
Yeah.
Okay. Jamie, you weren't here yesterday. You need those 3 Pythagorean identities memorized. You really only need to memorize the first one. I'm not even sure I'd say you need to memorize that because it's the Pythagorean Theorem. Okay, but the other 2 you can come up with by just dividing through by cosine squared and sine squared. Okay? And as we kind of just had to do on this problem, you can manipulate those Pythagorean identities to be equal to whatever you want them to be equal to. Okay? All right. So here's another one. Verify that cosine theta times secant theta equals 1. I better put that up here. Verify cosine theta times secant theta equals 1. Why is that true? What do you know? Go ahead.
The legs of the triangle are cosine and sine,
Okay,
and then if you square them and multiply them together, they equal 1 squared.
that's true. Does that help me here?
Well, if you multiply those two together, it equals 1.
Why? That's what I'm asking.
Oh.
Why does that equal 1? Now, we could go with what you were just saying and change this 1 into sine squared plus cosine squared, but I'm not sure it'll help me. We could try it.
Okay.
It's up to you.
Nah.
Nah.
Yeah, we'll see what someone else says. Well, I'll keep looking too.
Okay. We're trying to show that cosine theta times secant theta is equal to 1.
They're reciprocal.
Oh, they're reciprocals. So secant is the same thing as what?
Cosine or 1 over cosine.
1 over cosine. So cosine theta times secant is actually 1 over cosine theta. And then you can do what?
Multiply and get 1.
You can just
Oh.
reduce. And you get 1. So 1 equals 1. Done. No Pythagorean identities needed for this one. The Pythagorean identities are just tools you may need along the way. Okay, and these are not the only applications of them, but these are just some of them. Okay, now I want you to verify. You want to do another one or no?
Yeah.
Yeah?
Do you want them second? First and second.
So let's say I want to verify that secant theta plus tangent theta the quantity times secant theta minus tangent theta. That's equal to 1. I want to prove that that is equal to 1. Okay? So there's your dotted line. You can't cross it. What do you want to do? We need to work on one of these sides. FOIL might be what you meant. Put them together. Do the multiplication. Kind of begs to be done, doesn't it? Okay, so secant theta times secant theta. What's that give me?
Secant squared.
Secant squared theta. Secant theta times negative tangent theta is going to give me minus secant theta tangent theta. I'm going to run out of room if I keep writing that large. Positive tangent theta times secant theta is going to give me plus secant theta tangent theta. I'm going to write it in the same order I just wrote the previous term so that it's very obvious to you that they can combine. Okay? And then tangent theta times minus tangent theta is going to give me minus what?
Tangent squared theta.
Good. Minus tangent squared theta. Okay? What happens?
Cancel out the middle.
Those two cancel out. And I'm left with secant squared theta minus tangent squared theta.
Then you can just manipulate tangent squared theta plus 1 squared, plus 1 equals secant squared.
Very good. That's a form of the Pythagorean identity. Okay, I can subtract tangent squared theta over to this side of the Pythagorean identity and I'll be equal to 1. So that equals 1 and 1 equals 1. Done. Anytime you have squared Pythagorean or squared trig functions, or ones actually, either one, kind of should trigger to you that you might need a Pythagorean identity in order to verify. Okay, squared trig functions are kind of smacks in the face that you definitely may need a Pythagorean identity for this.
This is really weird.
It's really weird.
It's rather weird.
All right. Now we need to talk about how to evaluate things in your calculator. If you're told to evaluate, we already did some in radians. Okay? In order to evaluate in your calculator, it's going to depend on what mode you're in and what calculator you have. If I ask you to evaluate the tangent, most of you will have a tangent button, first of all. Okay? If you don't, you need to really be aware of and be comfortable with the relationship that tangent is sine over cosine. Okay, so how you plug these into your calculator is going to depend on which calculator you have. So let's talk about how to plug them in. Okay. So, can I erase what's on the board?
Yes.
Took a picture and you gave a really scary look.
A long time ago.
Oh.
You want to see it?
Got it?
So scared.
All right, so let's leave those trig identities up there. I think in that last problem, we kind of came across a good point. You can manipulate these trig identities to be in whatever form you want them in. If you have cosine squared in your problem, you might want to make this one equal to cosine squared. So you might want to subtract sine squared from both sides. All right, in your calculators,
I love this thing. It's so cool.
if I want to evaluate the tangent of 36.5 degrees, there are two things that I need to check. I need to make sure my calculator is in degree mode, okay? If you need help changing your calculator to degree mode, I'll help you with that in a minute. All right, so you need to make sure your calculator is in degrees for this problem because my angle measure is in degrees. The second thing you need to find is your tangent button. Now for some calculators, you'll need to type 36.5 first and then hit the tangent button. For other calculators, you'll hit the tangent button first and then hit 36.5. Someone who thinks they know how to use their calculator pretty well, go ahead and try that and tell me what you get. Tangent of 36.5 degrees is equal to what?
0.74.
What is it?
I got 0.74.
0.74?
That's rounded, but yeah. Yeah,
Okay.
that's a long number.
But 0.74 should be what you get. If you don't get that, we need to talk about how to do it. However, if I want to evaluate the secant, cosecant, or cotangent, I'm going to need to do a little bit more typing, okay? Because you don't have buttons that say secant, cosecant, and cotangent. The little buttons that have sine with a -1, cosine with a -1, and tangent with a -1 are not the reciprocals. They are the inverse functions, okay? It's like the difference between squaring and square rooting. It's a totally different function. It is not the reciprocal of your current function, okay? So let me tell you how you might type that in. All right, can I erase this? Are you okay? So if I want to evaluate, let's say, secant of 25 degrees. We'll keep it in degrees because you've already changed your calculators to degree mode. If you have a radian measure, it will have a pi with it, or it may not have a pi with it, but it will not have this little degree symbol after it. If a number does not have the little degree symbol, it is in radians. Okay, so if I want to take the secant of 25 degrees, that's the same thing as 1 over the cosine of 25 degrees. Okay, to type that into your calculator, it really depends on the calculator you have. Some calculators you can type in 1 divided by, and then the cosine of 25, okay, if you're in degree mode. Other calculators, you'll kind of have to type it in backwards, okay? You'll have to type in 25 and then hit the cosine button, and then type 1 divided by that rounded value. You'll have to write it down. However, sometimes there is a parenthesis button on calculators that you still have to type it in backwards. So you might be able to type it in this way if you have a parenthesis button. 1 divided by, then put a set of parentheses, and then hit 25, and then the cosine key, okay? It depends on your calculator whether you hit the cosine key before the 25 or after the 25. That one goes before the 25. So that one gets, the ones we gave you this year get typed as you write them, okay? If you have trouble typing something into your calculator, let me know. But for secant, cosecant, and cotangent, you're actually going to have to do the division appropriately, okay?
Do you know how to put these calculators in degree mode?
I do. I'll show you how to do it.
I'm not
Okay.
real quick.
I think we're good.